Hey guys, this is Mr. Grice for Algebra Unit 10.3 in-class practice, day number 2. Make sure you've got your graphing calculators out and ready to go. I got mine, so let's do this. Let's look at number 1. It says the table shows the value of a 1967, that's going to be important, Ford Mustang Shelby GT 500. Okay, and remember that it's going to be telling us the value is in thousands. So use your graphing calculator to create a scatter plot of the data or the table of values. So our X is the years after the purchase, and the Y is the value of the car in thousands. Okay? So go ahead and get your graphing calculator out. We're going to go to Stat, Edit. Oh man, I've got all this extra data in here. I'm going to clear that. And I'm going to clear it. So go ahead and plug in all of that information and we'll get started with number 1. Pause the video. Good luck. Okay, after we've gotten all the data in, remember that we have to go and check our window. Okay, so the lowest value for X is 2. So I'm going to put a 0 as my min. My X max, the highest number I see is 30, so I'm going to go a couple above that. Remember, X scale is 0. Our Y min, so guys, let me show you real quick that this was my, I used X min, I said 0. X max, I said 35 because of 30. Okay, and our Y min is 0. And then our Y max, the highest number that we see here is 57, so I'm going to say 60. Okay? And then you go ahead and graph it. All right, and your graph should look something like this. So what do you think this is? Is this linear, quadratic, or exponential? Right away you know it's not linear. And look at that curve. What happened? To the right it keeps going up, but as you go left it goes down, it goes down, it goes down, but then it goes back up, guys. That's not an exponential, that's quadratic. Okay? So the next part, now that we know that it's quadratic, we have to go to Stat, over to Calculate. Let's see, Stat, Calculate, sorry. And then we're going to go down to the quadratic regulation number 5. Okay? And that's what you guys should get. And we're going to use this information right now to create our equation. All right? So it asks us to round to the 5th decimal. So y equals 0.15474 x squared minus 3.54999x plus 22.80484 is what you should have gotten after you round everything. Okay? Question D. Use the equation to find the value of the city this year. Okay, well, what year is it right now? It's 2014. What year is the car? It's 1967, so we have to find the difference between those 2 years. So 2014 minus 1967, and what'd you get? Are you sure? Do you need to double check? Okay, I got 47 too. I just wanted to make sure. And what we have to do is we have to plug that value in to see what it's worth. So 0.15474. Okay, so what are you going to plug in? Okay, you should be plugging in the 47. Don't forget about your squares. All right, and when you get that answer, after you plug it in, you should get that y equals 197.77597. Okay, but they asked what is it worth? Remember that that is talking about thousands. So what it's actually worth would be $197,775.97. Woo! It's a pretty sweet deal if you ask me. Too bad I don't have that car in mint condition or have that car, period. All right, B. Find the year in which the car reached its minimum value. Okay, now they said the minimum value because as you look, see the graph goes up. So the middle, the bottom is the lowest point. All right, it's pretty much asking you to find the vertex. Okay, so when we find the vertex, we have to use the opposite of B over 2A. So the opposite of B, we've got the opposite of B. Well, which one's B? That's B. So the opposite of B would be 3.54999, and we're going to divide all of that by 2 times 0.15474. Okay? Now, when you're doing this in your calculator, okay, we have the 3.54999. We're dividing that, but first we want to do 2 times B. Okay, if you don't put the parentheses on the bottom, you will get something different than me. Okay, so, did I type that in right? 3.54999 times. So, rounding this up, okay, we get an answer, because we want this rounded, that x is approximately 12. Okay, so that's the first point. But now we want to know, what's it equal? Okay, so to find that out, we have to go back into our equation right here. And now we're plugging in 12. So go ahead, plug in 12. Tell me what you get. All right, you should get 2.4886. Now, a couple things. They want us to round to the nearest dollar. So this number would be $2,488.60. So that tells us that we have to round that to 2,489. So that's how much it costs, but what year was that? That was the year 1970, what? 1979, okay? Because we take that 12 and we add it to the year of the car, and we get 1979. So here we go. In 1979, the car cost $2,489. Woo! Got it all right. Now, let's go ahead and do this next one. So this is talking about a garden hose that sprays a stream of water across the lawn. The data shows the approximate height of the stream at various distances from the nozzle. All right, so you guys are in charge of creating the scatter plot and your window. Okay, so go ahead and pause the video and good luck. Okay, so if you look at here, this is how I set up my window so I could see. My x-min was -1, my x-max was 5, y-min is 0, and y-max is 3, because I just wanted to go a little bit higher. I went to -1 on the x just so I could really see, because it was on the line. That first point was on the line. Okay, now looking at this, I can tell it's a quadratic equation. So that should answer question B, that it's quadratic. And now let's go ahead and write the equation. So we're going to go to stat, over to calc, and it's quadratic. So that tells me that I have to do quad reg. Go ahead and hit enter on your calculator. And there you go. It tells us our A, our B, and our C. So remember to round to the 5th decimal. Okay? In case you forget, it says it right here, round to the 5th decimal. And you should get that y equals -0.36970x squared plus the 1.47879x. Be very careful with this. And 0.51515. Okay, so use the equation to approximate the height of the stream if it is 3.2 meters from the nozzle. Okay, and then it's asking us to round to the nearest tenth. Okay, so we need to plug into the equation. I know, remember, we gotta show our work. And we're plugging in 3.2. Oh, and I forgot to square it. Okay. So go ahead. What'd you guys get? If you need time, pause the video and do it right now. I'm going to do it right now. Okay, and you should have gotten 1.46. I guess you guys got to watch me do it because I forgot to hit pause. Good thing I wasn't singing or anything. All right, so we get that y equals 1.46. And the reason why I stopped there was because the directions tell us to round to the nearest decimal, or the tenth, I'm sorry. So y is equivalent to 1.5 meters. Don't forget to label your answer. Okay? And the last one, E. Find the distance from the nozzle the stream was when it reached its maximum height. What was the maximum height? Round to the nearest tenth, okay? So once again, guys, this is asking us for the vertex. The vertex is a point. We start with the opposite of b over 2a. So the opposite of b would be negative 1.47879, and we're going to divide that by 2 times negative 0.36970. Okay, so let's plug that into our calculators right now. Negative 1.47879, and I'm dividing that by 2 times that negative 0.36970. And I got 1.99999, just like that. And when we round that to the nearest tenth, it goes up, which means that changes to a 2. Okay? And then we're going to go ahead and plug that thing in to our equation right here. So we're going to take all of this. Man, I bet you guys wish you could do this right now. Okay? Except I'm not plugging in 3.2 anymore. Now I'm just going to plug in 2. And when you get that, and after you round, you should get an answer of 2. So the last thing to say, we got to write a sentence about this. So this is what I would say. So the stream reached a maximum height of 2 meters when it was 2 meters from the nozzle. Okay, so that's my final answer. I'm going to put a box around it. So we only went through these first 2 problems in class. The next day, we're going to go through the back side of this, okay? So that's going to be it for Algebra Unit 10.3 Notes, Day 2. If you have any questions, please come see Ms. Carranza or myself because we would love to help you out. Thanks for watching.